All right, so here is the solution for activity 2. The packages needed are going to be the same as for activity 1, and that's going to be pandas, scipy.stats, and numpy. The main block of code begins almost exactly the same. The Chipotle CSV is imported using read CSV to the data frame, or XLSX file using read Excel. And then we get a list of the values from 2 of the columns, female and healthy, important to me. Then next we need to remove all values that are null from these lists in order to run the chi-squared test. So in order to do this, we need to fill out these NaN arrays just like how we did in the previous activity. And we do that using the numpy.isNaN function, passing through whatever list we're working with. All right, so one thing you're going to want to notice is that there's 2 for loops this time as opposed to the 1 in activity 1. And so that is to step through each column's list of data values and then fill out these new lists that we've instantiated up here with non-null number values. So it's the same for I, val, and enumerate syntax. And then the if statement has been slightly modified. So this if statement ensures that this only executes if neither column's value in the given row is null. And that's because it has not, and then it checks the value of the NaN for this column at this location that val is at, and not, same thing for the health column. Okay, so the next part is basically filling out the chi-squared table. So the data that we're working with doesn't explicitly have the nice columns and rows that you see in the chi-squared table. So I had to kind of work with the data to fill out these counts. So I do this with another for loop, and this for loop is different than the one above. This is the more standard version of the for loop. And so the syntax is for index I, so whatever variable for the index, in, and then range, parentheses, len, parentheses, and then whichever list you want to use, but you have to use the updated list. That you can use either because they're the same size. Okay, and so basically what that does is it steps I through every value from 0 to 1 less than the length of this list. So basically that amounts to it's going to go through every single index that is in this list, and at each index it's going to call the value that is at that slot in the list using this method of retrieving a value from a list. And so if that value is 1, this is the female category from above. That means that the person who filled out the survey was a female. And so that progresses to this if statement, which determines if their preference for health, which is rated on a scale of 1 to 5, was greater than 3. I said greater than 3 is healthy preference, less than 3 is unhealthy preference. So once we've determined that the person for the given row is a female, then the next if statement determines whether or not they have a healthy or an unhealthy preference. So you have to initialize the variables at 0 up here in order to be able to use this syntax of adding a count to each one of these, like adding a tally. So you're going to want to take care of that above, and then for each variable, add 1 using the plus equals method to whatever category the given row qualifies for. So once you have the counts for male and female, healthy and unhealthy, you're going to want to go down here and create first the rows of male and female. And so that's going to have the count of healthy and the count of unhealthy for each. And that's going to be in a list, so that's surrounded by square brackets. And then once you do that and you have the rows for male and female, we want to combine the rows into a table by repeating the process and putting male and female in a list. So now you have the table that corresponds to any other like observed expected table. This would be the observed for chi-squared. And then you want to pass that into this function. This is scipy.stats.chi2 underscore contingency. And then parentheses, and the input is this table. So this function has 4 outputs: the test statistic, the p-value, degrees of freedom, and the expected table of values. So after that, we store each one of those values to these variables, and then print the p-value. All right, so finally we have the same if statement that we had in the previous activity. So it compares the p-value with the alpha of 0.05. If it's less than 0.05, it returns that it rejected the null, and otherwise it returns that it didn't reject the null. So I'll go ahead and run so you can see the output. And you'll see down here it shows you the p-value and that the null hypothesis was not rejected.